Yes, welcome students to this wonderful day. In the previous classes, we talked about much on what is an inventory model. Am I correct? The raw materials are coming in and then it moves out. So what is taking place in between these two times is called inventory model. Example, I told you computer company, book company, and also necessity. Why we have to study it? We have to study for so many reasons: smooth, efficient, and goodwill, best service, all those things. And we discussed about the first model on the day. First model is what? Uniform demand, infinite production, and no shortages. Okay, that is what the first model. The assumption we made: the uniform demand, or we have taken setup cost C3, holding cost C1, and then we got the picture for that. We formula, we got it. At last, we did one problem and we stopped and moved out. Okay, right. Now come to the second model. Okay, two more models are here. The second model is about this model. Look at that, is a model where the uniform demand is there, as we seen in the last class. Finite production, no shortages. What's the difference between this model? This is an infinite production, whereas this is a finite production and no shortages are allowed. Okay, so for to make the models for this mathematical model, first we have to assume something. So assumptions we have to make. What are the assumptions? Assumption, not assumption, assumptions. What assumptions we have to make here? Okay, so assumptions we have to make here. Okay, assumptions are this: demand rate we are taking as R, production rate we are taking as K, holding cost we are taking as C1, and setup cost we are assuming as C3. So wherever you see this see this particular notation, it indicates that this one. Okay, right hand side equals left hand side, left hand side equals right hand side. So these are the assumptions we have to make. Okay, right. So corresponding pictures, that's what we have to think of. Okay, the corresponding pictures for the second model is this, where see it is a inventory level. We are ordering this much of inventory, then it is coming down, down, down. But unlike in the previous cases, you see here only one triangle like coming here. Order is ordered, then it is coming, coming, coming. At last, it come to an end. But this is not so. This is a finite production. Therefore, if R is a total demand outside, then K minus R will be reducing, reducing, reducing. K is the production rate. Therefore, the product will be reduced in this particular rate, K minus R. So two triangles we have here in a single triangle. This is a time taken to reduce and this is a time taken to produce. Okay, so T1 and T2, two times are there, but this total time is T. This is a timeline. So for this particular triangle, the total time is T. For this particular triangle, the total time is T. Okay, right. If this is the case, then the formula is like this. Okay, so what's the formula here? What is the economic order quantity? I mean the optimal quantity we have to order in this particular situation. What is the situation here? Uniform demand, finite production, and no shortages. Then how much we have to order? We cannot order as we like. Am I correct? A particular a specified number of orders we have to order. Then only the production capacity or the inventory model will give favorable results to us. So economic order quantity or economic lot size, like that, so many names are called by. So that formula is given by square root of 2 into C3 divided by C1 into RK divided by K minus R. What is C1? It is a setup cost. C1 is what? Holding cost. And C3 is what? Setup cost. What is R? Rate of production. K, rate of production, or the total demand for a particular period. Okay, so if you calculate this will give you the economic order quantity for the given situation, this inventory models. Now the optimum interval, That means what? After which time we have to order each and every time. Take for example, is 1 year is the time period. Within 1 year, how many times we have to order? That's what T naught we say. That is nothing but Q naught divided by R. You calculate Q naught by this formula, then divide by the total expectation outside, total demand, you will get T naught. If you get T naught, then getting N naught is very easy. N naught means what? Optimum number of orders we have to make. Take for example, in 1 year, how many number of orders we have to take, and how many times we have to make order. For 5 times we have to order, or 6 times we have to order, like that. That is nothing but 1 by T naught. Okay. So the optimum cost, if this is a EOQ, this is an optimum interval. If this is an optimum number of orders we are placing, now what would be the optimum cost? Optimum cost, a cost favorable to us, not too much of loss or not too much of profit. Okay, and that cost is given by the formula square root of 2C1 C3 R K minus R divided by K. C1 C3 R defined as before. Now let me take one problem here. Okay, a yearly demand of a computers is 12,000. The production capacity is 24,000. A finite production capacity. Holding cost is rupees 1.50 per computer. Setup cost is rupees 500. If that is the case, what is the economic order quantity we have to calculate? Optimum time interval we have to calculate. Optimum number of orders we have to calculate, and optimum cost we have to calculate. So all these are given to us. R is 12,000, K is 24,000, C1 1.50, C3 400. If you substitute all these values in the formula given here, the yellow color formulas, you will get all we want here. Okay, so we are substituting that for all C3. What is C3? 400. R 12,000 into K 24,000 divided by K minus R 24,000 minus 12,000. C1 1.50, you will get 3.264 units. 3.264 units is the size of the order we have to make to get the optimum cost. Then all other formulas as we did before, the optimum time interval would be equal to Q naught divided by R equals 3.264 divided by 12,000, because R is the total demand. Q naught we have calculated just before, 3.264. We'll get 0.272 years. So every 0.272 years we have to order. Okay, the number of orders also is asked there. That is 1 by T naught that we can calculate. Now what is the optimum? What is the optimum cost? If we do show, okay, that optimum cost is given by the formula square root of 2 into C1 C3 into R K minus R divided by K. So which equals rupees 50,942. This is the optimum cost that we can get. Okay, that's what we have to. Okay, now let me continue with that. Now it is model 3. Model 3 is a uniform demand, instantaneous production, and with shortages. Here one thing added, that is called shortages. Instantaneous production means what? Any number of production can be made at a particular time. That's what is given there. It is not, we cannot say that it is finite production, or we cannot say that it is infinite production. It is an instantaneous production with uniform demand. Now for this model also we have to make assumptions like this. Okay, so uniform demand given, that we are taking as R. C1 we are taking as a holding cost. C2 we are taking as a shortage cost, and C3 as a setup cost. Okay, these are some of the assumptions we have to make. So with that assumption, a symbol is given here, and that's what we have to. Now corresponding picture is like this. Okay, because it's instantaneous production, the two things are here. A point, B point, C point. We are ordering. It is coming down, 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 and it is going. Then again it's coming down again and it goes up. That is what the instantaneous production. The total time taken is T. So there are two triangles here, upper triangle here, the lower triangle. Two triangles would be there. Okay. So that this is time taken 1, this is time taken 2. Okay, so this is the picture connected to the last model. Okay, now let me give me a formula for that. This is the formula corresponding to that last model. What's the last model? There's instantaneous production and shortages allowed, instantaneous production, uniform demand. So for that particular situation, the formula is given by, this is economic order quantity given by Q naught equals square root of C1 plus C2 divided by C2 into square root of 2C3R divided by C1. So what are C1, C2, C3 and R and C3? As we have assumed like this, R is the uniform demand, C1 is the holding cost, C2 is the shortage cost, and C3 is a setup cost. Okay, so that value we are substituting here, we will get the economic order quantity will get. That means the number of orders we have to make so that we will not face much loss in the company. T naught, as we described before, it is nothing but the quantity divided by R. The total demand will get T naught. N naught still very easy, 1 divided by T naught. And last, if we do so, what would be the cost, optimum cost we will get out of that? That's what we are interested here. So C naught would be equal to square root of C2 divided by C1 plus C2 to square root of 2 into C1 plus C3 R. These are the formulas for 3 models you have to remember. Okay, now let us take one problem here. Suppose R is 9,000. That means, take for example computers. The regular demand is 9,000. C1 is 2.40, C2 is 5, C3 is 100. As C1, C2, C3 are defined like this. C1 holding cost, shortage cost, setup cost. Holding cost is 2.40, setup cost is rupees 5, and here shortage cost is 100. If that is the case, what would be the economic order quantity? Look at this. This is economic order quantity formula. By substituting these values here, we will get 1053. Suppose this is a computer company, then the quantity every times the company have to order 1053 computers. Okay, right. How many times it has to order? The company has to order in a year. 8.55 times, approximately 9 times it has to order. With what interval it has to order? 0.117 year interval it has to order. Okay, this is the time interval between the orders. This is number of orders we have to make. This is the quantity of order we have to make. If do so, what would be the total optimum cost? This is given by the formula 9,000 into 1 plus square root of C2 plus C1. Substitute this, you will get rupees 10,710. This extra terms comes because unit cost is given to us, then we have to multiply the total demand by 1. Okay, the total demand by 1, then we have to add that with this particular optimum cost. The total cost would be 10,710 per year. Okay, so this is the way we can study these two models, last two models. Okay, the last two models. The second model is that uniform demand and finite production and no shortages. Last model is uniform demand, instantaneous production with shortages. So we have to remember all these things. There is no other way. Okay, so with that I'm coming to the end of this program. The next video I will come with another topic. Thank you very much, my dear students.